And that's how new Ralph Lauren clothes are made, from used apparel to the final product.
Inside this state-of-the-art facility, Ralph Lauren's new machines are transforming textile waste into high-quality fibers.
Every year, millions of tons of fashion waste end up in landfills. But here, the cycle is about to be broken.
It begins with the arrival of the unwanted. Bales of used clothing sourced from donation centers and retail take-back programs.
Before any recycling can happen, the sheer volume of material must be managed and staged for processing.
Hidden within these bales are premium cottons and polyester blends, valuable resources waiting to be unlocked. The automated transport system moves the textiles at a constant speed, feeding the ravenous machinery downstream.
Sophisticated logistics ensure that tons of material flow seamlessly through the plant without bottlenecks.
Optical sorters use infrared spectroscopy to identify the fiber makeup of every single garment in a fraction of a second.
Once sorted, the garments enter the mechanical shredders, beginning the physical breakdown of the fabric structure.
Every year, millions of tons of fashion waste end up in landfills. But here, the cycle is about to be reversed.
Before a single fiber can be reclaimed, the complex history of each garment must be unraveled. This facility operates at the intersection of brute force and chemical precision, guided by expert hands.
Initial inspection is critical. A single contaminant can compromise an entire batch of recycled fiber.
Once the containment wires are cut, the compressed garments expand to 10 times their shipping volume. The journey from discarded waste to raw resource begins on the primary feed line. Advanced optical sorters analyze the chemical signature of every garment in milliseconds. The journey begins on the intake line, where tons of sorted apparel are fed into the system. High-speed garnetting machines tear the fabric apart, fiber by fiber, undoing the work of the original loom.
The output is shoddy, a raw, chaotic, reclaimed fiber that serves as the base for new yarn.
Cyclonic separators use centrifugal force to eject heavy contaminants like buttons and zippers.
To ensure durability, the recycled fiber is intimately blended with high-grade virgin cotton.
Carding machines comb the chaotic mix into a gossamer web, aligning the fibers for the first time.
The aligned fibers are condensed into a thick rope called a sliver, collected in coils for the drawing frame. Drawing frames stretch and combine multiple slivers, ensuring the final yarn will be uniform and strong.
Inside the digester, a proprietary solvent targets the molecular bonds of the cotton, stripping away dyes and synthetic additives.
Once they're dissolved, the mixture becomes a homogeneous pulp, activated curatively to ensure
Separates. Before it can be reborn as thread, the solution travels through a multi-stage filtration system, removing microscopic debris. Passed over a series of heated rollers, the wet fibers are dried and stretched, aligning their internal structure to match the durability of virgin cotton.
After being cut and crimped, the fiber is baled, indistinguishable from raw cotton, and ready to re-enter the supply chain.
Quality control is rigorous. This recycled material must possess the same hand feel and durability as the original garment to be viable for the next collection. Before the material can be reborn, it must be completely deconstructed. The fiber opener acts as a giant willets. To ensure strength, the recycled shoddy is blended with organic virgin cotton. This cyclone mixes the fiber. The carding machine performs a task of microscopic precision. Millions of wire teeth comb the mixture.
Condensed into a soft rope called sliver, the material is incredibly fragile. It has form, but no...
Multiple strands are combined and stretched in the drawing frame. This aggressive elongation evens out imperfections, ensuring the final yarn will be uniform and durable.
Here, the fiber receives its first twist. It transforms into roving, a pencil-thick strand that
The ring spinning is where the transformation, high speed
Inside the primary reactor, proprietary solvents work to disentangle the complex weave of blended fabrics at a molecular level. Through high-speed filtration, the liquefied polyester is separated from the organic cotton solids, recovering two distinct streams of raw material. Nothing is wasted. The solvents are distilled, captured, and purified to be used again in a continuous, closed-loop cycle.
Precision cutters chop the strands into uniform pellets, chemically identical to virgin polyester but created entirely from waste.
Simultaneously, the recovered cotton cellulose is dried and fluffed, regaining the natural texture required for future weaving. Every batch undergoes rigorous testing to ensure the recycled fibers match the performance metrics of new materials.
Finally, the pellets are melted and extruded through spinnerets, creating brand new continuous filament yarn ready for the loom.
Before these shredded fibers can be spun, they must be conditioned to regain the pliability lost during their previous life as a garment. Carding combs the material into a single direction, removing the last impurities and aligning the fibers for strength. The web is condensed into a sliver, a soft, untwisted rope that serves as the foundation for the new thread. Drawing frames stretch and combine multiple slivers, blending them to ensure the final color and texture are perfectly uniform. At the roving frame, the fiber gets its first twist, transforming from a loose rope into a fragile strand ready for spinning.
This is the moment of creation. Ring spinning binds the recycled fibers into a yarn strong enough to rival virgin cotton.
Robotic winders consolidate the yarn onto large cones, using air splicers to remove imperfections without tying a single knot. Under the microscope, the recycled yarn shows its integrity, ready to begin a new life in a brand new garment.
The carding process is the first step in imposing order on the chaos of shredded apparel.
Inside the drum, millions of micro adjustments align the fibers, preparing them to become yarn once again.
Condensed into a continuous rope called a sliver, the material is now ready for the drawing frames.
By blending multiple slivers together, the machine eliminates irregularities, creating a consistent base for the new fabric.
The roving frame adds just enough twist to hold the fibers together, reducing them to a fraction of their original thickness.
At thousands of revolutions per minute, the spinning frame twists the delicate fibers into durable, high-tensile yarn. Under the microscope, we can see the fibers locking together, transforming loose fluff into a continuous structural element. Optical sensors scan every inch of the new yarn, removing imperfections before it is wound onto cones for weaving. At the molecular level, we strip the old fibers of their history, breaking down the polyester chains into a pure, liquid form. Impurities are filtered out with micron-level precision, leaving us with a raw material indistinguishable from virgin plastic. The liquid polymer is forced through a spinneret, reborn as thousands of continuous, pristine filaments. We stretch the fibers to align their molecules, adding the strength and texture needed for high-quality apparel. The continuous strands are chopped into staple fibers, creating a fluffy texture that feels just like cotton.
Carding machines comb the fibers into a single direction, preparing the chaotic mix for the precision of spinning.
Finally, the loose fibers are twisted tightly together, spinning the recycled material into strong, new yarn.
Optical sensors ensure perfection, guaranteeing that this recycled yarn is ready to be woven into something new.
At the molecular level, the old cotton is reborn, stripping away its past life to become a virgin-quality filament. The resulting yarn is stronger than traditional recycled cotton, mimicking the durability of synthetics without the plastic.
Before weaving can begin, thousands of individual strands must be aligned with mathematical perfection.
Industrial looms weave the recycled fibers at speeds that blur the human eye, locking the material into a new lattice. The result is a textile that feels identical to one made from fresh cotton, yet carries zero agricultural footprint. From the loom, the greige goods move to finishing, where the fabric will be stabilized and prepared for dyeing.
High-temperature scouring removes any impurities, opening the fibers to accept color later in the process. Finally, the fabric is heat set, locking in its dimensions to ensure the recycled garment maintains its shape.
To ensure the recycled yarn meets durability standards, the reclaimed fiber is blended with high-grade organic cotton.
The carding machine combs the mixture into a single direction, removing the last of the impurities and aligning the fibers for spinning.
Condensed into slivers, the material is coiled into cans, ready to be drawn out and twisted into durable thread.
Repeated drawing processes stretch the fibers further, blending them into a perfectly uniform consistency before they are spun. The roving frame thins the material out and adds a gentle twist, strengthening the fiber just enough to withstand the high speeds of the final spinner.
Automated winders package the yarn onto industrial cones, using air splicers to remove defects without leaving a single knot.
Before knitting begins, every inch of yarn is scanned electronically to ensure it meets Ralph Lauren's exacting specifications for softness and durability. At this stage, the recycled fibers are shorter than virgin cotton, requiring precise tension adjustments during spinning.
Automated optical sensors found for inspect the yarn perfections, ensuring that this recycled material is the exact one.
The yarn is fed into circular knitting machines, specifically calibrated to recreate the signature piqué mesh texture that defines the classic polo shirt.
Bastel. Under the microscope, the fabric reveals a structural integrity indistinguishable from virgin cotton, proving that
Finishing processes involving high-pressure steam stabilize the fabric, ensuring the recycled garment won't shrink or warp after it leaves the factory. Digital nesting software maximizes the yield from every yard of fabric, while automated cutters slice the pattern pieces with millimeter-perfect accuracy. Finally, the signature emblem is stitched into place, marking the completion of the journey from discarded waste to a premium, renewed product.
Once spun into new yarn, the material enters the knitting phase, where thousands of needles interlock the fibers.
Laser-guided optical sensors scan every inch of the material, ensuring the recycled textile meets the same rigorous quality standards as virgin cotton. Using a closed-loop dyeing system, the fabric is infused with color using significantly less water and energy than conventional methods.
The fabric is then stretched and heat set in the stenter frame, locking in the dimensions and ensuring the stability of the recycled weave.
Mechanical finishing rollers brush the surface, creating the signature soft texture without relying on heavy chemical softeners.
Digital nesting software guides laser cutters to slice the pattern pieces, maximizing yield and leaving almost no scrap material behind.
Even the embroidery thread is derived from recycled sources, stitched with precision to apply the final mark of quality.
Skilled technicians assemble the cut panels, transforming what was once waste into a structured, high-end garment ready for a second life.
Before packaging, the reconstituted fabric undergoes a thermal relaxation process to restore its original hand feel. Automated folding systems maintain geometric consistency that manual labor simply cannot match at this volume.
Even the packaging reflects the circular ethos, utilizing biodegradable materials and recycled plastics.
Logistics algorithms sort thousands of units per hour, preparing them for distribution centers worldwide.
Final palletization is fully autonomous, handling the heavy lifting required to move tons of recycled inventory.
This facility serves as a temporary holding ground for what was once considered garbage, now reborn as premium apparel.
Efficiency at the loading dock
ensures that the supply chain remained as sustainable as the manufacturing process. From a discarded garment to a brand new product, the loop is finally closed.
Every garment undergoes a rigorous quality control process to ensure the recycled fibers match the durability and feel of virgin cotton. Even the packaging reflects the mission, utilizing biodegradable materials to maintain the integrity of the circular life cycle.
Automated logistics systems prepare the inventory for global distribution, sealing the loop on the recycling process. From a chaotic pile of discarded clothes, we have created an orderly inventory of high-value products ready for a second life. These trucks will carry the regenerate apparel back to retail stores, replacing the need for garments made from raw resource extraction.
This facility represents a blueprint for the future of fashion, proving that waste is merely a resource in the wrong place.
By closing the loop, we reduce water usage, eliminate chemical waste, and prevent tons of textiles from entering landfills.
And that's how new Ralph Lauren clothes are made, from used apparel to the final product.